Hi, I'm Tutor Juliet. Welcome to Learn with Tutor Juliet. In today's lesson, we'll be answering a selected question from OCR GCSE Chemistry paper J250/10. Here's the question. Calculate the mass of magnesium chloride formed when 2.8 grams of magnesium carbonate reacts with hydrochloric acid. The relative formula masses of magnesium carbonate and magnesium chloride have been given as 84.3 and 95.3 respectively. Questions like this are best demystified using a method I call the CAL method. C stands for calculating moles, A stands for applying ratio, W stands for working to mass, CAW. We will be applying this method in solving this question. Here is the equation of the reaction. In order to get started, it is important that you write out all your parameters. Your parameters are the values provided in your question. It is important you do that because it helps you save time and also help you with the known and the unknown. So from the question, we have our relative formula masses for magnesium carbonate as 84.3. We have for magnesium chloride also as 95.3. We were given the mass of magnesium carbonate as 2.8 grams. These are the known. Let's apply our CAL method, CAW. We begin with calculating moles. We have a general formula for calculating moles, and that's moles equals mass, in this case, divided by the relative formula mass. From what we have here, we have the mass of magnesium carbonate and the relative formula mass of magnesium carbonate. These are our knowns, so it is possible and easy for us to calculate the moles of magnesium carbonate. We do that by substituting the values for mass and relative formula mass. That would give us 2.8 grams divided by 84.3. If you use your calculator, you would arrive at 0.0332. That's to 3 significant figures. It's important that you write your units, moles. So the number of moles of magnesium carbonate is 0.332. We've succeeded in applying our C, which is calculating moles. We move on to A, applying ratios. Our ratios will be from the equation of the reaction. From the equation of the reaction, you will find out that 1 mole of magnesium carbonate will give 1 mole of magnesium chloride. And so we say that our mole ratio is 1:1. That way, the number of moles of magnesium carbonate and magnesium chloride are equal. So, if the number of moles of magnesium carbonate is 0.0332 moles, like we have here, then the number of moles of magnesium chloride will also be 0.0332. So, we've succeeded in applying ratios. Let's write that out anyway. 0.0332 moles of magnesium carbonate will produce 0.0332 moles of magnesium chloride. We've succeeded in applying our A, and then we move on to working to mass, which is exactly what we have been asked to do. We will be applying this same formula, moles equals mass over relative formula mass, except that in this case, we are looking for the mass of magnesium chloride. And so, mass becomes number of moles multiplied by our relative formula mass. Or better still, we say mass of magnesium chloride, just so we can know exactly what we are calculating. Mass of magnesium chloride gives number of moles multiplied by the relative formula mass. So what's the number of moles of magnesium chloride? Remember, in our step 2, we arrived at 0.0032 moles. 0.0332 multiplied by the relative formula mass of magnesium chloride, which is 95.3. If you use your calculator, you would arrive at 3.16 grams to 2 decimal places. Now, it is important for you to include your units whenever you arrive at your answer. I hope you enjoyed today's lesson. Thanks for watching. If this helped, like the video and subscribe for more chemistry lessons. Do you have questions or a topic you want covered? Drop it in the comments. I'll see you in the next one. Bye for now.